to this walkthrough and introductory tutorial to Unilipid. You can see here UnityMol, that is one component of the experiment, and the other component, let me switch to a terminal, is a simulation that will connect to UnityMol. Here is the command line that you need to run. It will run on 2 threads. This is the executable. It has a number of inputs, an option to wait for a connection, and at the end a port to which it will connect. And if I run this, you can see a number of information is printed, and at the end it says awaiting connection. At this point I can switch back to Unity, where I need first to load the system I want to investigate. Here's the protein PDB file that corresponds to that. Now let me zoom a little bit out so that we can see the full system. Let me also hide here that right menu. So already you can see I have a 3D view here in the center, and I have 2 side views projected according to 2 axes that you can see down here. So you get at any point in time a good view of what's happening. And now I have that. I can here in this IMD menu use connect, because I am using default values, localhost and this port. And now you will see a few graphs will pop up and the system will start moving. This is because the starting position is not an energy minimum. Let me also hide now this menu that we don't need for now. And you can see here what we already explored in terms of insertion angle and insertion depth. You can see how it moves here through this space. That gives you a good overview of what is explored. And on the other 2 graphs you can see the associated energies. Here's the energy associated with the insertion angle, so you can see it's settling out at the minimum right now at about minus 469 and at about 60 degrees. And for the penetration, of course, the same energy goes, and the position is minus 5 angstrom into the membrane. And now what we can do simply with the mouse, tug on any part of this protein and then see what happens. For instance, I could just start to pull it out a little. So I will pull on this loop here, pull upwards, and then you can see that the penetration, it goes up here. You can see this in the energy, and it explores a little. Yeah, sorry, it goes down because I did use the inverted axis, sorry. The axis is to the down. And so then it tries to settle back into this minimum, particularly the angle here. It's not quite getting there, so I can push it now down inside the membrane again. And that will bring it closer to this point here, you can see. So I don't do anything anymore, I just let it relax. And you can see it settles in close to one of the former minima that were recorded here, as one would expect. Of course, the other thing one can probe is also the angle. Let's say now I will try not to move too much the penetration depth, but I'm trying to lie it down in the membrane to see whether anything happens here, and you can see again how it oscillates and tries to find with what I explored. Of course I can also go to another direction here, because I turn, let's put it like this, and also we move about. And you can of course be a bit more violent in your exploration, even so that the thing changes orientation. I almost turned it around completely, and I can turn back. And let's see where it will end up. You can see it is trying to pull itself up, but we have of course now reached a different local minimum that it seems not to be able to escape from. But I know that there are better minima, so I can just nudge it out of this local minimum, see whether it finds itself the way to where I want it to be. It doesn't seem the case, so I'm a little bit more directive, and you see I pushed it back into this zone that we explored in the beginning. So all this just to give you a small idea. Of course, if I'm hindered by these plots, I can hide them with this arrow here, right? So you can see the full system, and you can see it's started to insert in an angle. Maybe you also want a different representation for this, so I can just go here and, for instance, add a representation. Let's add hyperboles, and then in the hyperboles let's choose van der Waals and color it, which would make sense, by hydrophobicity, and then you can get an idea of whether the insertion that the system came up with is coherent with the hydrophobicity. So you should see the strongest hydrophobic parts be inserted here, which seems to be the case. And of course you can also manipulate in this position here. Try not to be too strong. And pull up the plots again. And so you can see we kind of systematically seem to fall onto this little minimum here. Let's see whether we can put it a little bit further down, whether that makes any sense. We went up in energy again, and we seem to be falling down into the same local minimum. Just pushing it around a little bit just to see what are the other. You see, there we found a nice, interesting minimum that is a bit lower, and even here now we have a lower minimum. And you also can see that this landscape of the insertion is actually quite rugged. There are several local minima that are relatively close by. And the already very first thing that you see for this system is it definitely does not want to stay straight up in the membrane. Now let's just see if we can pull it around. So here you can see it is moving quite a lot. This is because I lowered actually the inertia. This is one of the settings in the simulations. So of course such interactive simulations very much depend also on the settings you have, and you can actually change them interactively. I will not go into details here, just show you one setting that you get the idea of that. So if you go up here in the menu in BioSpring, you will find the IMD tools, which are interactive simulation tools. In the parameters here you have, for instance, the viscosity, and in my input file I set it very low. And now if I set it to this default value here, so let's put 0.01 for instance, I think this is a nice one, and do send parameters, you will see that it will be oscillating much less. Okay, that is because the viscosity is damping it quite a lot. So in this way, so this viscosity is quite strong. This will allow you to position at a specific insertion depth and angle if you want to be able to precisely choose a given orientation. Right, like here so. And then when I'm happy, I just lower this viscosity again. That will free the system, maybe even lower than that. And then you can see it just moved a little bit. So the force that is now acting on it is sufficient to overcome the inertia and to try to see where it can adjust further. And I think the value I had in my demo was this one here. So now we should be back to the initial setting where it is very, let's say, nervous, as you can see. If I give it a tug, it will continue to grow. And now if I go back here, factor of 10 up already, it should slow down. Maybe not sufficient. Another one, now it slows very quickly. And there are more simulation parameters, and I will explain them slowly in another tutorial. But for our first, this is basically what you need to know to be able to start these types of simulations. Let me put it straight again. And you see now I'm actually exploring quite a different space with respect to what we had previously, but I'm still almost at the initial energy minimum that we were seeing. Okay, that's it for this tutorial. Thank you for following.